See Lindelof videos, ti-nspire CAS. I'm going to do a Rolle's theorem problem using a trig function on a closed interval, and the CAS can do something that is unexpected for the AP reader, so it's really cool that you'll be able to get this answer relatively quickly. So here's the problem that I came up with. Find all values of c that satisfy Rolle's theorem for y is equal to sine of 2x on the closed interval negative pi to pi. So this is all I'm going to do here. Hopefully you can see this, and I hope I'm not assuming too much, but hopefully you can see this, that if this is true, then y prime is equal to, let me get out of that, is equal to 2 cosine 2x. That's the first derivative, isn't it? On negative pi to pi. So if you can't do that, then watch my other video for how to take derivatives of trigonometric functions. But this much should be easy. So all I'm going to do from here is go to the calculator section. So I'm going to go to calculator. And what I'm going to do is this. I'm going to trick my calculator a tiny bit. I'm going to go to this catalog right here, and I'm going to set up this piecewise function. It's going to offer you 3 pieces. I'm just going to take one and say OK here. And then I'm just going to set that up. We know that the function is 2 times, right, cosine. So I go to trig here. You could type in if you want. Cosine 2x. I'm going to tab over into this condition, and I'm just going to set that up, and I'm going to set it up as negative pi is less than or equal to x, and x is less than or equal to pi, right? And that was the condition that we started with, wasn't it? Now here's where you can screw up with the calculator. I did it like 5 times. I finally called somebody, and I got a stupid, horrible answer. But anyway, I did figure it out. What you have to do is, you're still in that little box right here. You're here, so you got to get out of it just by hitting tab, and then hit Control Store. And I'm going to go ahead and call this thing, I don't know, I'll call it g of x, I guess, g of x. And hit enter, and it says done, which seems pretty anticlimactic. But something really, really cool just happened. Instead of getting this cosine function that goes over and over and over and over and over again, what we've done is we've only graphed it out here. And more than that, we can solve. Remember, Rolle's theorem says that if our function on closed AB is continuous and differentiable on open AB, then there's some place on open AB that the slope goes to 0. So that's all I'm going to do. I'm going to use my solve function, so I'll just type in solve g of x is equal to 0 in right comma, that's in terms of x. Now remember, because this thing graphs on such a small part, it's just going to give me the answers I wanted. Right? This is huge, because otherwise you're going to keep getting your answers back in terms of n, and it's not helpful at all. You know, if you have a second, let me show you what is happening here. Here's the graph. If we graph 2 times cosine 2x, right? 2 cosine 2x, right? And then we have to follow all this crap and figure out where our answer is. However, if I graph just that g of x function, it would slim it down a little bit, wouldn't it? So I'm going to graph g of x. G of x, remember I saved this thing as g of x. I can just put it in like that. G of x. And seeing this in orange, it shows us just the part we are interested in. So it can give us real answers back. And even better than that, because you have a CAS calculator, your CAS calculator gives it back to you in symbolic language. That means in terms of pi, if that's appropriate. Where if you use any other calculator, it gives you back a numeric solution in decimal form or whatever it comes up with. So, all right, you guys, thanks for watching the video. If you have any comments or questions, let me know. And if you haven't already subscribed, please subscribe. Thanks, I appreciate it.